question has two statements. The first statement, when an acidic solution of permanganate is treated with hydrogen peroxide, it turns colorless with the evolution of oxygen gas, whereas an acidic solution of Fe2 plus ions on treatment with hydrogen peroxide turns yellow-brown. The second statement, hydrogen peroxide can act as an oxidizing agent as well as a reducing agent in acidic medium. Now we will check whether this first statement is true or false. When acidic solution of permanganate is mixed with hydrogen peroxide, a redox reaction takes place. During this redox reaction, permanganate ions reduce to manganese 2 plus ions and hydrogen peroxide oxidize to oxygen gas. Oxidation state of manganese in permanganate ion is +7 and the oxidation state of manganese in manganese 2 plus ion is +2. Therefore, during this reduction process, 5 electrons has been involved. Oxidation state of oxygen in hydrogen peroxide is -1 and the oxidation state of oxygen in oxygen molecule is 0. Therefore, during this oxidation process, 1 electron is involved per 1 oxygen atom. But hydrogen peroxide molecule contains 2 oxygen atoms as well as oxygen molecule contains 2 oxygen atoms. Therefore, the total number of electrons involved in this oxidation process is 2 electrons. Next, balance the number of electrons. 5 electrons multiplied by 2 at the same time multiplied permanganate and manganese 2 plus by 2 and then 2 multiplied by 5. At the same time multiply hydrogen peroxide and oxygen by 5. Next, balance the number of oxygen atoms. 10 oxygen atoms on the right and 18 oxygen atoms on the left. Therefore, add 8 water molecules to the right. Finally, balance the number of hydrogen atoms by adding H plus ions. 16 hydrogen atoms on the right and 10 hydrogen atoms on the left. Therefore, add 6H plus to the left. This is the balanced ionic equation for the reaction between permanganate and hydrogen peroxide in acidic media. To get the answer of the question, what we need is only the observation of this reaction. Now we will see the products. Permanganate ions reduces to manganese 2 plus. Color of permanganate. Color of permanganate is violet and manganese 2 plus in aqueous solution, it appears as a colorless solution. Then hydrogen peroxide oxidizes to oxygen gas. Therefore, we can see the evolution of oxygen gas bubbles. When an acidic solution of Fe2 plus ions react with hydrogen peroxide, Fe2 plus ions oxidize to Fe3 plus ions and hydrogen peroxide reduce to water. Oxidation state of iron in Fe2 plus ion is +2 and oxidation state of iron in Fe3 plus ion is +3. Therefore, 1 electron is involved in this oxidation process. Oxidation state of oxygen in hydrogen peroxide is -1. Oxidation state of oxygen in water molecule is -2. Hydrogen peroxide has 2 oxygen atoms. Therefore, first balance the number of atoms which undergoes reduction. So we can use the coefficient 2 for water. Number of electrons involved in the reduction process per one oxygen atom is 1 electron. The difference between these two oxidation states is just 1 electron, but hydrogen peroxide has 2 oxygen atoms and both oxygen atoms undergo reduction and forms 2 water molecules. Therefore, total number of electrons involved in this reduction process is 2 electrons. Next, balance the number of electrons. The oxidation we can multiply it by 2. Therefore, add coefficient 2 for both Fe2 plus and Fe3 plus. Next, balance the number of oxygen atoms. 2 oxygen atoms on the right and 2 oxygen atoms on the left. Therefore, oxygen atoms is already balanced. Finally, balance the number of hydrogen atoms. 4 hydrogen atoms on the right and 2 hydrogen atoms on the left. Therefore, add 2 H plus ions to the left. This is the balanced ionic equation for the reaction between Fe2 plus ions and hydrogen peroxide in acidic medium. But for this question, what we need is only the observation of this reaction. Color of aqueous Fe2 plus solution is pale green. During the reaction, Fe2 plus ions convert to Fe3 plus ions. Color of aqueous Fe3 plus ion solution is yellow-brown. Therefore, during this reaction, pale green color of this aqueous Fe2 plus ion solution is converted to yellow-brown color due to the formation of aqueous Fe3 plus ions. Now we will go back to the question. The first statement, when an acidic solution of permanganate is treated with hydrogen peroxide, it turns colorless. That is correct because of the formation of manganese 2 plus ions with the evolution of oxygen gas. Whereas an acidic solution of Fe2 plus ions on treatment with hydrogen peroxide turns yellow-brown. That is also correct due to the formation of Fe3 plus ions. Hydrogen peroxide can act as an oxidizing agent or it can act as a reducing agent. When hydrogen peroxide undergoes oxidation, it converts to oxygen gas. Therefore, during this process, hydrogen peroxide acts as a reducing agent. When hydrogen peroxide undergoes reduction, it converts to water. Therefore, when hydrogen peroxide converts to water, it acts as an oxidizing agent. Now we will move to the second statement. Hydrogen peroxide can act as an oxidizing agent as well as a reducing agent in acidic medium. It can act as an oxidizing agent as well as it can act as a reducing agent. Then we will see about the medium. The redox property of hydrogen peroxide depends on the pH of the medium, but hydrogen peroxide can act as an oxidizing agent as well as a reducing agent in both acidic as well as basic medium. Therefore, the second statement is correct. Now we will check the answer. Both statements are correct. Therefore, we can remove third, fourth and fifth responses. So we have only two responses, either 1 or 2. If the second statement correctly explains the first statement, the answer is 1. If the second statement does not explain the first statement, the answer is 2. The first statement gives two redox reactions of hydrogen peroxide in acidic medium. During the first reaction, hydrogen peroxide oxidized to oxygen gas while permanganate ions reduced to manganese 2 plus ions. Therefore, hydrogen peroxide is act as a reducing agent during this reaction. The second reaction, hydrogen peroxide reduced to water while Fe2 plus ions oxidized to Fe3 plus ions. Therefore, hydrogen peroxide acts as an oxidizing agent during the second reaction. The second statement says hydrogen peroxide can act as an oxidizing agent as well as a reducing agent in acidic media. Therefore, this second statement correctly explains the first statement. The answer is number 1.